In the first problem, we're given an angled force vector, but we don't know what the angle is. Let's go ahead and draw the rest of our forces in the free body diagram. And let's go ahead and convert this angle into its components. Even though you don't know what the angle is, you can still leave it as a variable and solve for the x component and the y component. So the x component is going to be 43 cosine of whatever your angle is, and the y component is going to be 43 sine of whatever the angle is. So now let's take a look at Newton's second law in the x direction. In the problem, it states that we are at constant velocity. So remember, that means that acceleration is 0. So the entire right half of Newton's second law is going to go to 0. Your two forces are the cosine component of the applied force vector and the force of friction. We can set those two equal to one another and then use our inverse cosine function to solve for the angle theta. In this video, we're going to skip number 10 and 11 and go straight to 12. We're given a velocity in kilometers per hour. That's no good. Let's go ahead and convert that to meters per second. Okay, now that we got that out of the way, this is pretty much the same as those diving board problems that we've been doing. We have the distance in the y direction given, so let's plug in everything that we know. In the x direction, we only know the initial velocity. In the y direction, we know the initial velocity is 0 because we're only starting with a velocity in the x direction. We know the distance, and we know the acceleration because we are on planet Earth. So let's find the time first. We always use the y direction to find the time. You can use this kinematics equation right here. I'll plug in the numbers for you. Don't forget to make your distance negative, and then go ahead and solve for time. Now once you have that, you can go look at your x direction again. And the question is, how far does it travel in the x direction? Or how far away is it in the case of this particular word problem? But we can just multiply the velocity times the time to get the distance. Number 13 is a similar problem. We're given the distance in the y direction and the distance in the x direction, but no velocities. We know that our velocity initial in the y direction is 0 because we are only running straight off of the cliff. Okay, so we can solve for time using the y direction here. Now that we have the time of his entire trip, the diver's entire fall, we can plug that back into the x direction to solve for the velocity required in order to clear the rocks that are 23 meters away. Here we're throwing a dart horizontally. We are given the distance that the dart falls in the y direction. So let's plug in what we know. Okay, looks like we need to find time, so let's go ahead and use our kinematics equation here to find time using the y direction. Don't forget to make that distance negative. Let me pause the video right here and add a little, I always forget to do this, don't I? The little negative there. Okay, if you don't do it, it'll mean you have you'll have to take the square root of a negative number. So if you run into that situation, just go ahead and make it positive, because you probably just made the same mistake that I did. Okay, and then once we have the time, we can find the distance in the x direction using distance equals velocity times time. Alright, I hope that this was helpful.